So I said last Saturday we'd have a look at the H407 Harvard base station. I thought I'd got 3 of these, I've actually only got 1. So we were going to sell off a surplus one, and I've discovered I've got 2 of the H404, so we'll be offering that one to somebody who's asked for that. So it won't be the H407, it'll be the H404, and they can have the one we did last week. So H407, this is the more popular one. It's exactly the same as the H404 we did last week. These aren't never the right screws, I'm absolutely sure. I'm sure they're supposed to be black M3s, and these are self-tappers. Now we'll have been through this set before, but 20 years ago. So for completeness of videos of every UK legal set, mind you, I think we'll be putting this one through the dishwasher. There we go. How do people get paint on things like this? And how do we get it off? Don't know. Well, what we're going to start and do on this one is we're going to start by changing the capacitors in the power supply whether they need to it or not. This has clearly been in a smoking household at one time, as it's a bit brown with nicotine. Back in the days of CRT televisions, that really affected them. So we looked at the capacitors last week. It may not be necessary, but just for the exercise we will do. These radios are virtually a Sanyo product, the Cybernet made in Japan, 002F chassis, but nearly every part in them is Sanyo. And I just find that the Sanyo chassis, as I'm now going to start calling it, it seems to be about the most reliable there is. So that's interesting. The P-clip that the capacitor's in, you want the screws that way on, so that is very awkward to get to. No, I definitely want to change those capacitors just for this exercise. I'm going to pause the video, we'll get the board out. Okay, so it wasn't as scary as I first thought. I managed to get this board out, and I've changed the 2 electrolytic capacitors which are on that board. So it's just a matter of 2 self-tapper screws that goes through that heatsink. Oh no, they're not self-tappers, they're machine screws. M3 machine screws. So awkward but not impossible. Now this capacitor, I found it, because the way they've put the screw into the P-clip, I found it easier to unbolt it from the bottom of the chassis. So we'll take that off. And hopefully we've got a capacitor in stock that isn't stupidly too big. You'll notice I didn't power this up first, so there was no charge on these capacitors, because I'm sure we must be good. Can't be possible that we've powered it up for 15 years, I'm sure. So we'll test these capacitors. It's probably totally unnecessary because of the quality of the original components, but we'll see. At the end of the day, this is my set, it's not a customer's, so I'm not kind of spending their money. These are wrapped round and round. One out. Good grief, how many times did they wrap this one around? I think they were expecting to hold up the Eiffel Tower with that. So there we are, 33, I just touched the hot wire. 3300 at 35 volts. And I seem to recall I've got a 40 volt one already in stock, which I thought was too small a diameter. It's not that far out, to be honest. You know what? That'll do. Yeah, 40 volt one. So a bit of a size difference, but it's more in length. So we haven't got tags because these days getting ones with tags on are a bit few and far between, and we wanted to get the right diameter. So it's going to be a matter of soldering to the pins. So what we'll do, I think we'll cut some of this excess wire off. Okay, so we've got those back together. So it wasn't as scary as I thought it was going to be. The 40 volt capacitor replaces the 35 volt capacitor, fits in the clip, and everything else is the same. We've upped the voltages to 35 volts there from 16 volts, and yeah, both 16 volts. And what else have we done? Oh, 105 degrees, because that's all we seem to order these days. So I'll plug this into the mains. The switches are in the dishwasher, the knobs, that's the word I'm looking for. And I need to switch that on. Okay. And we have a dead set. That's because that needs to be in the AC position. Now we're lit up. So we'll get the meter. We'll see what's coming out. So we can see where it goes into the radio, the power that is, and it's just there. 13.76. So we probably set this up 15-20 years ago, and it's despite the new parts, it's about there. 13.8. That suits me. Now I haven't got the ESR meter on this bench today, so we'll just do a quick capacitance check on what we took out. So 9.5 microfarads, it's supposed to be 10, so that was fine. Throw it away. .47 microfarads, it's supposed to be 47. Throw it away. And then this enormous by today's standards. Just make sure that's discharged, even though it's not been on for donkeys. 3,800. That's a little high, and that can be indicative of imminent failure in the future. So throw that away. I haven't got a microphone for this. I think I took it off and put it somewhere. I think it was a Palmer replacement mic. Let's see if we've got a standard replacement mic that we normally use. Sounds like that's the right one. Turn the volume down. Set to just plug that into the back of the set. See if we can hear the signal generator. And that's currently parked at 0.3 of a microvolt. Now, just in case we didn't do this 20 years ago, we will do the VCO. So it's channel 1 on these sets. Capacitor 9. That's not very stable. Interesting. Okay, so we're on a proper earth. We've got 2.09, and we could adjust that. There we are, 2. So going to transmit. It's supposed to have something like the same on transmit. Got that. Just the trimmer. Go back to receive, 2.01, go to channel 40, 3.5 and 3.63 on transmit. That's fine. It didn't need adjusting, of course, because I've done it previously, but there you go. That was 20 years ago. So we'll look at what we're getting on transmit. So switch on picture in picture. And I'll stand up to make sure it's showing on the monitor. It is. So I've just got over 3 watts. Oops, I'm on channel 40. Easiest trick in the book, that. Back to channel 20. Peak. Peak. Change tools. There's no difficulty in getting the full 4 watts. There we go. Let's look at low power. Should be 0.4 of a watt. It's 0.25 of a watt. It's not adjustable. It really doesn't matter. And we'll see what the meter says on the front. Oh, helps if we're going to full power. There we go. So we should be on the centre of the red zone. It's exactly in the centre of the red zone. And it's the adjustment is there. Centre of the red zone. Deviation. Wow, this would have been done on a different test set. This was. Oh yeah, what's happening here? This would have been done on our Farnell test set. It's reading a bit high on deviation, so we'll just deal with that. What? Oh, I'm in the wrong mode. It's just a little bit high. Wallow, that's it. So I reckon that covers our transmit. I can hear it receiving. So I think the best course of action is to do the detector. So we'll go over to the oscilloscope, we'll switch the oscilloscope on, and we'll put the camera on the oscilloscope. That's a point we've not done the frequency. Right, I better plug in the extension speaker so the instruments are connected. S9 signal and signal generator. Yeah, a little tiny bit of a difference there, but it's neither here nor there. So we'll now look at the cyanide meter. I'll tell you what, we'll backtrack and look at the frequency. Yeah, it's nearly spot on. Just pull that up a fraction if it'll go. There we go. So let's see what the sensitivity is at present. 0.28 microvolts. Excellent. See if we can just get a fraction more out of it. I doubt it. There's a bigger signal on. With a much bigger signal on, just make sure they're spot on. See if we've gained anything. 0.27, so yeah. So very, very good. S meter. It's a bit beyond where it should be, so we'll just do that. I think it's that one. So we should have S9. And then we'll do squelch. So put the squelch on full, which is fun with no knobs. And let's see where it comes in. So put this onto the attenuator so we can all see. So at the moment it's 1 microvolt, 3 microvolts, 10, 30. I want it to be later than that. Probably about there now. So turn the signal generator to standby, set threshold, switch back on. It's coming straight in, so it's coming in at, no it's not, it's coming in at, being one of those, is it? It's just not coming quite in on my scale, so it's coming in at about 0.33. So let's try and get a finer reading. So I'll go on to the next scale. So now 0.2, 0.3. It's 0.4 actually it's coming in at. And then we're losing it at 0.12, you know, excellent. So considering the squelch can let these down, that's working quite well. It needs the knobs putting back on, and it needs the TX light to find its way back into the bezel, because at the moment it isn't quite on show. So whether or not it's been changed, I mean this has had work over the years, you can tell. See whether there's something we can do easily. See if there's a screwdriver we can get in. No. Put that meter away, which is now in the way. Okay, so we move on to the next day. We're now on Sunday. Just tying up some loose ends, and we're actually can do an on the air thing. Right, we'll just run through these channels. 19 Roger. Well, it wasn't like yesterday when we got that lady breaker. One nine, Roger. No, nothing. Okay, well, we're doing on the air test with Mr. Chippy then later on. And there's the Harvard H407. Tomorrow I think we're doing a realistic 1012 hand portable, which has come in bits. And while we're doing that one, I'll do one of my own, which is not a radio we've covered before. I don't think we've got any circuits or anything for it. So thanks for watching.